This is a presentation on the National Coastal Change Assessment, or Scotland's Dynamic Coast, which was given at the European Climate Change Adaptation Conference in Glasgow in June. My name's Alistair Rennie. I'm presenting on behalf of Jim Hansom and James Fitton, both at Glasgow University. So what are the drivers for the research? Well, simply, we didn't have answers to the following questions. What's the extent and location of the eroding and potentially erodable coastline in Scotland? What's the extent and rate of coastal change over time? Where are the vulnerable areas of the coast? What social, economic and cultural heritage assets may be affected? These have been categorised as a knowledge gap, but there's also a question as far as a policy implementation gap. How can we use and improve the existing policy mechanisms to increase society's resilience? And how can we maximise the benefits with minimum costs? So what are the key policies? Well, the Climate Change Act, or the Climate Change Scotland Act in 2009, places a duty on the Scottish Government to address the risks in the UK climate change risk assessment. The Government have chosen to lay these out clearly within the Climate Change Adaptation Programme. As such, the Government has shown some very clear leadership and also some very clear duties for the public sector across Scotland in taking forward work to address these risks. There are other bits of legislation like the Flood Risk Management Act that also support this area of work. So what's expected? Well, rising sea levels, more coastal erosion and associated increases in coastal flooding are expected to increasingly affect Scotland's soft coastline, its assets and its communities. Maps of past erosion, current state and future erosion conditions are required. And we're supposed to put in place adaptive measures for our natural and cultural heritage. We've been asked to consider the implications of coastal erosion for all of Scotland's assets, I should say. That's why the Scotland's National Coastal Change Assessment was commissioned. It started in December 2014 and has concluded in March 2017. The results can be found at dynamiccoast.com. The work has been funded by CREW. It's a Scottish Government project, and our steering committee can be seen on this slide here. We're grateful for their support over the few years. So how do we appreciate past erosion? We've compared georectified historical and modern maps. So we've taken old maps like this one dating from the 1890s for St Andrews, and we've ensured its position correctly. We then identify where the shoreline is. This is the high water mark of ordinary spring tides. And then we've compared that with the same position on later, more recent maps. So that's the 1970s maps, and again we pull out the mean high water springs position. It's the same position as the earlier map, just with a different title or a different description, but it's the same line in essence. We've then compared that with a recent three-dimensional surface from a LiDAR survey in 2011 in this instance, and pulled out again the current position of the shoreline. That enables us to see on the eastern flank of St Andrews here accretion as the shoreline has built out since the 1890s, but a little area of erosion has also happened here between 1890 and actually the 1970s, and there's been stability since. Of course, the past doesn't always continue into the future, but it's least likely to be challenged legally, this approach. So what we're saying is, as we project into the future, this is a best guess or a best clue to how future change may occur. Such an approach underpins the shoreline management plans where they exist in Scotland. However, we only project erosion inland into areas that are actually erodible. and we've used a model called the Coastal Erosion Susceptibility Model that was developed by Glasgow University for, again, crew funded amongst other work, to appreciate how erodible the land is. There's a poster available that summarises this work, and that's available on the Dynamic Coast website as well. So where is the soft coast? Well, this bar chart running across the middle depicts the entire coastline, 100% of Scotland's coastline. 78% is hard and mixed, unlikely to be eroded. 19% is soft and potentially erodible. And 3% is artificial, sitting behind coastal defences. Now, whilst the example shown earlier used a LiDAR surface to show where the modern shoreline was, we also used the Ordnance Survey lines because they're obviously reliable and available across areas that we don't have LiDAR surface. So we've checked the position of the soft coast in all 4,000 kilometres of it, and some of these were found out to be out of date as far as the Ordnance Survey mapping's been concerned. This has been reflown. They've had a very busy 2016 flying season, and progress continues into 2017. We've used the LiDAR surface to update mean high water springs, and this again will be incorporated within the OS data to ensure that the lines on the maps that everyone's used to seeing remain reliable. Together, very large amounts, terabytes of data have been analysed to appreciate our dynamic coast at a level of detail that has never been achieved before. We have 50 project partners, and the ask from government was to consider the implications for all of society's interests. The results come in a couple of different formats. Again, I'd encourage you to go to dynamiccoast.com and you'll be able to see the web maps and also a series of reports which are going through quality assurance at the moment. The underlying data will be made available to local authorities, government and public bodies to ensure that they are able to use that in their statutory work. It's also available online for the public as well through the web maps that are available through dynamiccoast.com. So what do the web maps show? They show the position of the shoreline in 1890, in the 1970s, and the current shoreline, and they also project it forward to show where erosion may end up in the future. So what we've done here is we've taken the recent rate of change since the 1970s to the modern shoreline and taken that annual rate of change and continued it landwards. So the red area is expected to be seaward of mean high water springs, is expected to be eroded. These maps here compare very well with a similar methodology that's been used by Angus Council within their shoreline management plan. So you can see on this insert here a black line, which is their anticipated coastline in 2100 if recent rates continue. It's a similar method developing a similar output. You would ask why we're doing this if actually Angus Council have actually undertaken similar exercises in their area. Why are we repeating this at a national level? Well, not all areas of the coastline have shoreline management plans. In fact, the minority do. So there's large bits of the coastline that don't have these sorts of assessments, and that's the aim of the NCCA, is to ensure there's a more even evidence base to enable all to be able to consider which assets are at increased risk from erosion. So, looking at the character of Scotland's coast then, with a couple of pictures to depict this, you can see that the hard and mixed coast, for example, the foreshore at St Andrews has been classified as hard and mixed. The brown bits seen in these pie charts dominate particularly the west coast and north coast. The soft sand dunes, the soft coast, the sand dunes at St Andrews, are shown as pale yellow, and you can see the proportion of yellow bits in the pie chart is larger on the east coast. We've got a larger percentage of the coast on the east coast is made up of sands and softer sediments, And similarly, when we look at Grangemouth here as an example of an artificial shoreline, you can see the grey bits of the pie. There are certain bits of the coast, principally the east coast and the Clyde, that have been engineered. They're artificial shores. So there's larger sections of that. So you can see the distribution of the coast and the characteristics within each. Now we're concentrating on the yellow bits, and we've basically done the change analysis on those yellow bits. So taking the bar chart again, within the soft coast, we've considered how it's changed through time. So taking the first two maps then, the first period, 1890 to 1970, of the area that's soft coast that may change, we've seen 8% retreat landward, experience erosion, 78% remain stable or move insignificantly, and 14% advanced. Now these results are normalised for the time period, which is important to ensure that when we compare the past period and the recent period, it's over the same duration. Coming forward, comparing the position of the shoreline from the 1970s to the modern time period, you can see that a similar amount of the coastline has remained stable, around 3/4, 77%. But the amount of coastline that's retreated or experienced erosion has increased to 12%. The amount of coastline that's advanced seawards, we've seen gains, is 11%. When we consider the expansion of erosion and the contraction of accretion, then there's been a 39% increase in the extent of erosion between the two time periods. There's been a 22% decrease in the extent of accretion. Now these lengths over which the coastline has changed can also be considered in a different way. We can also not just look at the extents that have changed, but also the rates of change on those areas. And we've seen that there's a doubling of the erosion rate from 0.5 metre to closer to 1 metre, and a doubling of the accretion rate from 0.7 to 1.5 metres per year. So where we are having change, the change is quicker. We're having more erosion and less accretion than we had in the past. Whilst that's quite a simple national message, it dilutes more significant changes and patterns in different parts of the country. So considering the shoreline as a whole, we can see the recent changes here, with greys showing stability on the soft coast, greens showing accretion on the soft coast, and reds showing erosion on the soft coast. And there's a general pattern here. You can see that this part of the country, mainly the west coast and the north coast, has more enclosed coastal cells. So although we're only looking at the sandy bits or the soft bits of these shorelines, the surrounding rocky coastline is quite indented, and that offers protection to the adjacent soft sections. The result of which is there's lots of stability. These pie charts all have lots of grey in them, and that's stability on the soft coast as a result of the surrounding hard coast that offers the protection. The beaches are more protected on the west coast and north coast from the surrounding rocky shores. Contrasting this, the east coast, we can see a smaller amount of grey within the pie chart, a smaller amount of stability, and a greater amount of change in reds and greens. And that's because we believe these parts of the coastline, these coastal cells, are more open, more exposed, and offer and receive less protection than the other bits of coast we've just talked about. So our interpretation here is there is a natural protective function of the adjacent rocky shore which is influencing the soft coast mobility. So what's behind each of these red bits? Well, you can see that the extent of erosion varies around the coast, and what we've done is, where we've believed that erosion to be significant, and that's where the coastline has retreated more than 10 metres, we've projected that recent rate forward up to 2050. Where erosion is less than 10 metres, that's insignificant, and we haven't projected it forward. So taking that erosion rate forward into time, you can project the coastline inland, and if there are assets, for example a road in the back of the beach here, then it would be that section of road that we would be identifying within the mapping. Now we accept that this is a simple linear approach, but arguably it's the least worst method that we have available to us, and it's the one that's used within shoreline management plans more generally. Taken together, where recent erosion is greater than 10 metres, and if that recent erosion rate continues to 2050, then 50 buildings, 5.2 kilometres of roadway and 1.6 kilometres of railway, 2.4 kilometres of water pipes are expected to be eroded if things continue as they are. Having these data sets together, we can then ask questions as far as whether some of them are clustering with each other. So, where we expect septic water tanks to be eroded, then there also is a strong likelihood of buildings also being affected by the erosion. Where we have cultural heritage, castles and designed landscapes and such like, you can see that there's some coincidence with buildings and roads, but a far greater coincidence with natural heritage. Such an analysis allows different bits of the government to work out who it is we need to be speaking to ensure that when we are addressing these risks, we're considering opportunities and benefits of those other bits of government and the state who have a shared interest in these locations. However, this analysis is spatially limited. It's only the red bits, only the bits where we're certain there has been change that's significant, greater than 10 metres, that we've projected forward. That projection forward doesn't include the acceleration in the extent of erosion. It doesn't include any changes in management. If a local authority or a landowner decides to defend a beach or feed the beach with sediments, then we don't know that, and we haven't had the ability to incorporate that within the results. There's also no consideration of climate change here, so we haven't accelerated these erosion rates to take into consideration sea level rise, for example. Taking all this together, it's likely then that this list of assets that are at risk is an underestimate. It also begs the question, how is the distribution of erosion changing through time? So we can compare the extent of erosion happening in different bits of the coastline from the historical period into the recent period. And again, there's an interesting division within the results. Taking the enclosed protected cells of the west coast and the north coast, where the rocky coastline surrounding the soft coast offers some protection, the changes have been more modest. You can see a smaller number of arrows in this map, showing where erosion is increasing and decreasing with the direction of the arrow, and the number of arrows shows the scale of change. Same with accretion as the green box, erosion on the red box. So you can see we've got relatively few arrows going up and down here. Contrasting that, you can see that the east coast, the changes in erosion are much more significant, and they're increasing. The changes in accretion are more modest. So the greatest changes since the 1970s is seen on exposed cells, with more modest changes occurring within the enclosed cells. We've considered what other assets, or what assets are close to the coast more generally. So that looks at, it takes a 50-metre buffer around the edge of the coastline for the entire country, and then considers how many community services, residential property, non-residential property, rail, roadways and so on and so forth are located within those areas. Now these are indicative for various different reasons, but in essence there are 30,000 buildings, 1,500 septic water tanks, 1,300 kilometres of road and 100 kilometres of rail. What we find, and the point of this slide is to identify that there's a large proportion of them that are located on the soft coast. So 26% of the non-residential property is located on the soft coast. Similarly, of the residential property that's within 50 metres, 29% are located on the soft coast. Interestingly, of the railway that's running within 50 metres of the coastline, 56% is located on the soft coast. So this tells us that between a third and a half of the assets within the coastal strip of 50 metres are located on the soft coast, which only makes up 19% of our coastline. If you're questioning whether a 50-metre buffer is a bit generous, well, 5% of the soft coast has eroded more than 30 metres since the 1970s. So this isn't a terrible stretch to consider these assets as close to the coast. Again, the distribution of each of these can be considered within each of the different cells, broken down by different coastal types, and again these results are available within different reports. So the interpretation is the East Coast contains a lot of assets close to the coast, and they're of course the bits of coast that's most exposed to coastal erosion and the changes. But also, more importantly, there's lots of bars, there's lots of interests in each of the cells. So no asset type is immune, no coastal cell is immune, and all cells have erodible assets. So the conclusion from the results then is 19% of Scotland's coastline is soft and has the potential to erode. It's been termed erodible. 35% of coastal buildings and assets are located on this soft coast. Since the 1970s, 77% of the coast has remained stable, 11% has accreted seawards. We've seen gains here, 11% has accreted seawards, and 12% has eroded landwards. Taken together, this tells us that the natural coastal defences are successfully defending 88% of Scotland's soft coast. Thus, the sustainable management of our natural capital is vital to protect essential services and economic growth in Scotland. Put succinctly, nature can help us cope with climate change. But what we can also see within the results is there's been a 39% increase in the extent of erosion, a 22% reduction in the extent of accretion. Average erosion rates have doubled, and average accretion rates have almost doubled as well. These observations are consistent with climate change, and therefore it's likely that climate change is affecting coastal erosion, much like it is affecting coastal flooding. Conclusions for the future. Projecting the known erosion forward has identified all asset types are at risk. But given the observations, the current distribution of erosion, the changes in extent of erosion, and the increased rate of erosion, and that climate change impacts, including sea level rise, have been excluded from this analysis looking ahead, then more assets are likely to be at risk by 2050 as erosion quickens and expands into new areas. Those coastal cells at greatest risk are inherently more susceptible to erosion, with a higher percentage of soft coast, and have more coastal assets within them. They have less natural resilience due to the protection offered by the surrounding hard rock geology, but also due to the effects or the consequences of the installation of defences and dredging, which remove sediment from the system. So, considering climate change, there's a growing need for coastal erosion and flooding to be considered together, as both are anticipated to worsen in the coming decades. Given the observed changes, a window of opportunity now exists to plan, mitigate, and adapt in advance to avoid widespread unnecessary harm and cost. Cross-sector and integrated adaptation and mitigation planning is now required. And arguably, the best way to do that and coordinate that is through the Scottish Climate Change Adaptation Plan programme, which is designed specifically to do that. So, to hear how and if Scotland can deliver the adaptation required, please see Jim's presentation, which is also available on the website. I'd like to thank the steering committee, who are named on the right hand side here, for their support, and of course Crew, our funders. Thanks for listening. Happy to receive any questions by email, contact details, and obviously all the other materials are available on dynamiccoast.com. Thank you very much.